Let us talk about student t-test today. This test was developed by Gosset in 1998, and on his nickname it is known as student's t-test. This test is basically a test of significance. It helps us to determine whether two different data are significantly different or not. There are two types of student t-test. One is called paired t-test, and that is also called dependent or correlated t-test, and another is called unpaired t-test, that is independent t-test. So as the name suggests, this independent t-test is about two different groups. There are two groups in fact. Group 1, say group A, and group B. There are two groups of students, two groups of plants, two groups of animals, among which you are comparing the different types of data, like maybe it may be body weight, it may be height of the plant, it may be yield of a particular crop. So whether the difference between these two groups is significantly different or the same. So a number of observations are made, and say suppose you are comparing the body weight of fishes between two ponds, you are getting results like 50 gram, 70 gram, 60 gram, 65 gram, 55 gram, 58 grams. So these are the difference between these two is significant enough or it is nominal. This can be calculated by unpaired t-test. The paired t-test is about a single group. The group is one. There is a single group of students, people, plants, whatever, and the group is being, the time of taking the data is different. You have taken before data, I mean at the zero level. Probably you are taking the, suppose you are taking the weight of some children that are malnutrited, and you have got suppose 20 children and you have taken the weight of them. After giving them a particular nutritional supplement, for example, you are again weighing the kids, and you get a different data, a little increase in the body mass. So whether this increase in body mass is significant enough and it has occurred because of the nutritional supplement or not can be decided, can be tested by these paired t-tests. The formula for them rather is this. It is difference of the mean of two groups divided by the standard error of difference of mean. So the t-value is same for both of them, but the standard error of difference in case of paired t-test is equal to square of the standard error mean of the first data plus the square of the standard error mean of the second data, not the group. This is before and this is after, minus 2 into correlation into standard error mean of first data into standard error mean of the second data. So this is the standard error of difference of mean for the paired t-test. For unpaired t-test, this is SED is equal to standard deviation, combined standard deviation of the two groups divided square root of, multiplied by square root of 1 by n1 plus 1 by n2. So n1 and n2 are the number of observations for the two groups. So this is how the t-value for the t-test is calculated. Then this t-value, the t-value that is obtained is compared with the t-distribution table, where the degree of freedom for paired t-test is number of observation, number of individuals in the group. Say if it is 20, the degree of freedom will be 20 minus 1, that is 19. Degree of freedom for unpaired group will be the addition of the two, n1 plus n2 minus 2. This will be the degree of freedom. Here it is n minus 1. So this is the difference. If there are two groups with 10 individuals each, so the degree of freedom will be 10 plus 10 minus 2 equal to 18. And you have to see in the distribution table at particular degree of freedom and at particular, say, 0.05 probability level, what is the value given there. The table, if the table value is greater than your value, calculated value, then your null hypothesis is accepted. And if the table value is less than your obtained value, then your null hypothesis is rejected. The null hypothesis usually says that the difference between these two values, whether it is paired or unpaired, is not so significant. The alternate hypothesis is the data is significant. So this is how student t-test is calculated. Let us first see the paired t-test. The paired t-test, see here there is an example of a group of students, group of 10 students, and they were taken an exam, and the marks are like this. In the before a particular training session, the marks are like this, and after a training session of maybe 6 months, the score is like this. So whether the increase or decrease of the scores and the difference in the mean is significant or insignificant, that can be assessed by a paired t-test. The formula for both the t-tests is basically t is equal to difference of mean of the two groups or two data of a single group divided by standard error of difference between the mean. This is also this question is also used for paired unpaired t-test also, but the difference between the pair and the unpaired is this value. In case of paired t-test, this SED is equal to square root of the long term, that is SEX, standard error mean of x1, that is this one, first data, whole square, or you may keep this bracket away, only the first bracket is here, plus SEX2 whole square minus 2 into correlation value into SEX1 into SEX2. So this is the value for standard error. Because here a correlation factor is included, because this is correlated, a single group is there, and whether the training has a positive effect or negative effect, whether it is positively correlated or negatively correlated, so correlation factor is important. As the correlation increases, the t-value will decrease. So this is very important in case of a paired t-test. In unpaired t-test, where the two groups are there, the groups are different and time is same, the value of SED is given as standard deviation square root of 1 by n1 plus 1 by n2. So this is the value of standard error of difference in mean in these two types of tests. Now let us examine using this particular equation, how the value of t-test can be calculated with these two data. Let's clear these all and start the process. The null hypothesis says that the difference between these two groups, the result that is obtained between two groups is not so significant. So it is not so significant. The null hypothesis is not so significant. And the alternative hypothesis is, yeah, they are very, very significant. Now let us prove which of them has to be rejected and which one has to be accepted. See, the formula for this is x1 minus x2, the mean of the two. The first, we should find out the mean first. And then the SED value has to be found out. For that, we saw that we have to calculate the standard error for mean of x1 and also standard error for mean of x2, because this was equal to square root of SEX1 square plus SEX2 square minus 2 into R. So we have to calculate also R, the correlation value, and multiply it with SEX1 into SEX2. So these values has to be calculated. To calculate standard error for x1 or standard error for x2, we have to know the standard deviation also of both x1 and x2. Standard deviation is represented as sigma x1 sigma x2 has to be determined, because standard error is equal to the standard deviation, that is sigma, divided by the square root of n, where n is the number of individuals, number of observations. So the number of observations of individual is 10. So this will be the, we have to calculate these things first. So now let us find the mean value of them. The mean is equal to average of this to this, and so the mean of this is also same. The standard deviation for both of them is STDV. It can be calculated by calculating the deviation first and then squaring the deviation to find out the variance, and square root of variance is the standard deviation. It can be tabulated in that way also. Here in Excel you can directly get it like this. Okay, so this is the standard deviation. The standard mean is equal to standard deviation divided by square root of this number of observations that was made. So some error has occurred. We can directly write here 10. Oh no, this is this error, square root SQRT. So this is the value. Let me calculate first this into this value here or here. The square of the first one is like this. This given 2 is the square of this, and again this value, this symbol, and square of that. This is the same. Multiplication of that, no, not multiplication, addition. So the sum of them, sum of this and this is this value. Okay. So after calculating this value, that is the summation of the squares of standard error means of these two data. Now let us find the product of them, that is equal to the standard error mean of x1 into the standard error mean for x2, and the mean that was calculated earlier was wrong, so I have deleted it. Earlier it was deducted, the standard deviations were detected by wrongly because the selection of cells were wrong. So actually it is this is the mean minus this is the second mean. So it is minus 5.2 is the value. Now let us calculate the correlation now. Correlation is equal to the first array of data, comma, the second array of data. So this is the correlation value. It can also be calculated by a normal mathematical method that I will show you after a while how it can be done. So you have now this summation of the squares of the mean, you have the product of the means, and you have also the correlation. So we can now calculate this standard error of difference of means, that is SED value. So let us now first calculate without the square root. So this is the product of the this is the summation of the squares of the mean minus 2 into correlation data into the product of the means. So this gives you the value. Let us square it, square root it. So find out the value of square root of this same. So it is 2.0210009. Now we have got the numerator as well as the denominator. This is the numerator and this is the denominator. So just by dividing the numerator by denominator, we will get the t value. This divided by this. So we got this value. Okay. So this is the value of t. You can omit the negative sign because that is not important here. Yes, so the value is 2.572986. 2.57, you can consider that. Now let us compare it with the t distribution table. The degree of freedom here will be, since there are 10 observations, the degree of freedom will be 10 minus 1, that is 9. So at 9 degree of freedom and at 0.05 probability, the value is 1.883 in the t-distribution. It is 1.883 at t is equal to, at alpha is equal to 0.05 and degree of freedom is 9. So since this value is the table value is less than the calculated value, or in other words the calculated value is greater than the table value, the null hypothesis stands rejected. That is the difference between these two groups, the mass difference of mass, and the difference of mass of the mean of the difference of mass is significant, because the null hypothesis says it is not significant. Null hypothesis stands rejected here. The alternative hypothesis is accepted, which says that these two values are highly significant. This is how the pair t-test helps us to distinguish between two data and to find out the significance level of that. Thanks for watching.